Hey folks, Mr. Mathblog here, and this lesson is on multiplying a fraction or mixed number by a whole number. We're going to do both, okay? So this is lesson 8.4, and our common core is pretty much the same here, but we're going to, how can we multiply a fraction or a mixed number by a whole number to solve problems? So we're going to do a couple of ways here. I'm going to show you some old knowledge here. So we're going to access our prior knowledge here. How can we write the mixed numbers as fractions? I'm going to show you a few ways here. So one way is to recognize this 1 and 1/4 is the same as 1 plus 1/4. And I'm going to change this 1 with 4/4 right there because anything over itself equals 1. Remember that right there. So instead of having 1 plus 1/4, it's now 4/4 plus 1/4. And now I can go ahead and add those. And 4/4 plus 1/4, you add the numerators and you get 5/4. Okay, I'm going to do the same with this one right here. And this 3, I'm going to write it as 5/5 3 times. So 5/5 plus 5/5 plus 5/5 is my 3 right there, plus 2/5. Okay, and then we can go ahead and add 5 plus 5 is 10, plus 5 more is 15, plus 2 more is going to get me 17/5. Okay, all right, so there's a trick on this, you guys. We can go ahead and you can multiply the denominator with the whole number. So if I multiplied, say this one right here, this denominator right here, 5, with this whole number here, 3, okay, and then we add that product, so 5 times 3 is 15. I'm going to add that product with the numerator, which is 15 plus 2 is 17. That'll be my new numerator, which would be 17/5, okay? So I did 5 times 3 is 15 plus 2 is 17. That's where I got the 17/5. Do you remember that? I mentioned that in one of the other videos also. Let's try that with this one right here, you guys. So I'm going to multiply 4 times 9 is 36, and then 36 plus 2 is going to get me 38 right there, okay? So I did, well, 9 times 4 is 36, and then I added 36 plus 2, so I get 38/9 on that, okay? Easy enough. All right, so here we go. Let's see. Carter is planning a judo routine. At the end of each cycle, he will make 1 1/4 turns. How many turns will he make after 3 cycles? Okay, let's answer a couple of questions. So, will Carter make more or less than 1 1/4 turns in the 3 cycles? Well, I think that's pretty easy to see, you guys. Since we're doing 1 1/4 turns, 1 1/4 turns for each cycle, and he's going to do 3 of them, well, he's definitely going to do more than that. And so what operation are we going to use? Well, we can either use addition or multiplication. I'm going to choose multiplication with this one, okay? So here we go. So we're going to multiply 3 times 1 1/4. So I'm going to change 1 1/4 to an improper fraction right here. Okay, so that becomes 5/4 right there. And then we're going to go ahead and multiply. Remember from the last lesson, we just multiply the whole number times the numerator. So 3 times 5 is 15. It becomes 15/4. Okay, now let's write that as a mixed number again. So I'm going to change 15/4 to, okay, here's the long way to do it, you guys. 15/4 is, here's my 15/1/4 when I add them all together. So 4 of them, and these ones in black right here, here's 4 of them. This equals 1, okay? And then 4 more is going to equal another 1. And then 4 more is going to equal another 1. And then we have the leftover 3 of them. So the leftover is 3/4 right there. Okay, so 1 plus 1 plus 1 is going to get me 3, plus this 3/4 right here is 3 3/4. Okay, so Carter will make 3 3/4 turns after the 3 cycles. All right, so explain how writing the mixed number as a fraction in this step is related to division. Okay, so you can divide to find the number of equal groups. So since we're talking about fourth, if each group contains 4 fourth-size parts, then if we take 15 right here, this top number, and divide it by 4, we get 3 with the remainder of 3 left over. Okay, so that tells you that there's going to be 3 equal groups of fourth-size parts with 3/4 of the size left over. This is what I like to do, you guys, is I divide the bottom number into the top number. 4 goes into 15 3 times with 3 left over. So it goes in there 3 times with this 3 left over. So it's 3 3/4, okay? All right, so if you multiply 3 times 1/4, is that product greater than or less than 3? Well, since 1/4, you guys, is less than 1, then 3 groups of 1/4 will be less than 3 groups of 1, and 3 groups of 1 equals 3. So I know that 3 times 1/4 will be less than 3 that way. Okay, how can you tell that 3 times 1 and 1/4 is greater than 3 without finding the exact product? Well, kind of like above here, since this is greater than 1, then 3 times this is going to be greater than 3. Okay, so I said something like that. So since we know that 1 and 1/4 is greater than 1, then 3 times 1 and 1/4 must be greater than 3 times 1. Okay, so here we're going to rename mixed numbers and fractions. So we'll use multiplication and division to rename fractions and mixed numbers. So for an example, let's write 8 and 1/5 as a fraction. Okay, so I saw it directed in a book like this, you guys. So now we can go ahead and multiply it. I like doing the fast way. I'll do that at the end right here. So remember, 8 and 1/5 is the same as 8 plus 1/5. Okay, so it's going to be 8 times, and I'm going to change 8 times, this says use the identity property of multiplication. The identity property of multiplication just means you can multiply anything times 1, and that'll still equal that number. So 8 times 1 would still equal 8. Okay, and then I'm going to rename 1 in terms of fifths. So I'm going to change this to 5/5 right here. So that 1 is going to become 5/5. Okay, and then when I multiply this whole number times this fraction, I just multiply 8 times 5. That's going to get me 40/5, okay? Plus that 1/5 right there, and then we can go ahead and add 40 plus 1 is 41/5. Okay, now remember the old school way or the faster way, I think, you guys, I like this way the best. 5 times 8 is 40. 40 plus 1 is 41, so that's where we can get 41 fifths right there. Okay, this way is my favorite right there, by the way. Okay, but your book might have you do the other way. Okay, write 32 fifths as a mixed number. Okay, so we're going to find out how many groups of 5/5 are in 32 fifths. So we're going to divide 32 divided by 5. Okay, so here we go, 32 divided by 5. We're going to have a remainder here. Okay, so we're going to find out how many times does 5 go into 32. Well, 30 or 5 times 6 equals 30, so I'm going to put a 6 up there and put a 30 down there. Okay, and then I'm going to subtract and get a remainder of 2, and that's what's going to go right here. Okay, and then how I like to write this is I start at the top and go 6 and 2/5. Okay, so the answer is going to be there are 6 groups of 5/5 or 6 wholes, and there's 2/5 left over, so it's going to be 6 and 2/5 right there. Okay, I just like to think of this. You know, you don't even need to write with the remainder right there. Start at the top, 6 and 2/5. That's how I like to think of this right there. Go clockwise. All right, so find 2 times 3 and 3/4. Write the product as a mixed number. Okay, so what I'm going to do is change 3 and 3/4 to a fraction. So I'm going to go 4 times 3 is 12. 12 plus 3 is 15, so this equals 15/4. So that's what I'm going to put right there. Okay. All right, and then I'm going to go ahead and multiply. Going to multiply 2 times 15, and that's going to be all over 4. Okay, so I multiply the whole number times the numerator. 2 times 15 is 30, so I get 30 over 4. All right, now we're going to divide the numerator divided by this 4 right there. So 4 goes into 30 7 times, and it gives me 4 times 7 is 28, so there'll be 2 left over. So it's going to be 7 and 2/4. Okay, so it's how many times does the bottom number go into the top number? And it goes in there 7 times. 4 times 7 is 28, and there's going to be 2 left over. Okay, so there's I can divide it in there 7 times with 2 left over. All right, so explain why our solution to 2 times 3 and 3/4 is a reasonable answer. Okay, remember 2 times 3 and 3/4 is 7 and 2/4 right here. Well, it's a reasonable answer because since 3 and 3/4 is greater than 3, and I know that 2 times 3 equals 6, then 2 times 3 and 3/4 is going to be greater than 6. And since 7 and 2/4 is greater than 6, our solution is going to be a reasonable solution because it's a little bit greater than 6. Okay? All right, so does this make sense or does it make nonsense? So to find 2 times 3 at 3/4, Paige says she can find 2 times 3 plus 2 times 3/4. And so does this make sense and explain? Well, I'm going to agree with Paige, you guys, because I think Paige is on a good track right here because she's thinking that 3 and 3/4 is the same as 3 plus 3/4. And then so if I multiply 2 times 3/4, it's the same as 2 times 3 plus 3/4. And then you can use the distributive property and do 2 times 3, that's what this says, plus 2 times 3/4. That's what this says right here. So we used, Paige used the distributive property with that. Okay, so 2 times 3 plus 2 times 3/4 is the same as 2 times 3 plus 3/4 right there. So nice work, Paige. All right, so she would have got the same answer, 7 and 2/4 the same way, because 2 times 3 is 6, okay? And then 2 times 3/4, I multiply this 2 times the top number right here times the numerator. 2 times 3 is 6, 6/4, and 6/4 reduces, 4 goes into 6 one time with 2 left over, so 1 and 2/4. So 6 plus 1 and 2/4 is 7 and 2/4. Alrighty, okay, don't forget to, if you have your own YouTube account and you're watching this at home, please like and subscribe, and take care, everybody.